start with a brief, in brief introduction on this topic. I think it is very critical topic of our time, right? And integrated mobility and energy systems. So, if Professor Astrid is here, if if you want to start with your opening note, I will be happy to hand it over to you.
Yeah, thanks, Jibus. Thanks a lot. Actually, I wanted to hand over to you, but if you want, of course, I can make my first statements on the role of AI in energy systems and, of course, mobility and energy systems, as this is obviously the topic of this nice conference here. So, as you heard, my expertise is mainly in the application of distributed systems in the energy transformation, and I would like to give you a very short overview what our thoughts are in that area, because this is, I think, the main point to understand the outlook and the potential of the technologies we are talking about. So our main motivation is actually within the transformation of energy systems. Transformation that is definitely needed because we see that we want to be climate neutral in all sectors. And this leads us actually to the second part. So electrification is needed. Why do we need electrification? Because we see a lot of efficiency potential when we change from primary energy sources like coal, like oil, like gas, directly to producing electrical power systems. So electrical power gives us the opportunity to reduce our general load when we look at the primary energy sources that we need. So that is a very important point here. So first of all, what we have to do is to shift our needs towards electricity, because we don't want to lose a lot of primary energy. That is a very important point. So electrification is the main point. So when we go on, we come to the point of flexibility in energy systems, and that is our first link to mobility within this area, because once we have a large share of renewable energies, of course, we have to be more flexible. We do not have this large delivery of electric power into the systems that comes the same whole time, but on the other hand, we do not have this on the load side as well. So we are volatile on both sides of this medal. And that is an important point that often is missed in the discussion. We always say, oh, renewable energies are so volatile. Well, loads are as well. So an important point here to see that flexibility can be taken from both sides. So that's an important point. Flexibility is key here. And of course, mobility is one of the key aspects here, because when we go into the direction of electrified mobility, we see many possibilities to use flexibility from this area. That is not only in loading, but in unloading, so vehicle to grid concepts that might be addressed here as well. But when you see this only as one example of flexibility, we see a lot of other possibilities. Of course, we do have different storage opportunities. We do have load shifting. We have aspects of demand side management, of demand response in the system. And all this gives us different aspects of flexibility in the system. So now let's move to the next point. What is special in energy systems? Energy systems actually are critical infrastructures. And well, our main point what this forum is about is actually application of artificial intelligence. So application of artificial intelligence in critical infrastructures gives us new challenges, of course. Let me take only one example to, well, maybe show this main point, what we are working on, is actually that we are in an area where we have critical infrastructures. We call them cyber-physical energy systems, and of course mobility is a part of this. Once we are in an electrified system, we have connected storages used by electric mobility here. And we see that, of course, this is a system that has to be secured in a special way. That's not only on the safety side, that is traditional, but it's on the security and IT security side. And for example, we can apply many AI methods in the area of anomaly detection. So what is happening actually in the communication between the different systems? Do we see any anomalies? Do we have to take some parts of the system off the communication to ensure this? And there are many different methods within AI that are applied for this area. And this maybe gives you this whole view in very, very few minutes. Actually, it took me about 6 minutes, if I'm right here. So we come from the transformation of energy systems. We go into the direction of efficiency by electrification. Then we are, fourth point, in the flexibility discussion. This brings us to mobility in critical infrastructures, and there are different application areas for AI in that area. Just as a very short motivation on AI in energy systems connected with mobility. Jibo.
Well, short but very, how do you say, concentrated. I just, I have to admit, without any shame, that my knowledge in AI in energy systems is not, not great, and I just felt like I got a crash course just by listening to you. Now, coming to the other side of the point, let me give a little bit introduction on AI in integrated mobility, right? I mean, to continuing from where you speak, I think it's one of the biggest problem we have is optimizing, how do I say, the movement, the traffic, and other systems. And according, I mean, if you look at numbers, right, there is this organization called INRIX. So it's based out of Washington, and they provide location-based data and analyze and real-time traffic conditions. Now, there are numbers that says that every year the traffic congestion in US costs $100 per American, right? And that translates into like $1,400 per year. Now, if you take the overall number in the year 2017 alone, this loss is around $300 billion. And this number is increasing by $10 billion every year. So it's a very urgent matter that we use technologies such as AI and other emerging tools to optimize this kind of mobility systems, right, and create that. And one more reason I'm very happy to have this conversation is it is very refreshing and interesting to speak about AI other than ChatGPT and language models, right? I think people have to understand that AI has other areas of impact as well, right? Now, we mentioned this cost in numbers and in financial numbers, but it goes beyond that. There is also the opportunity cost for each person. At the same time, the overall monetary expense, right, that's imposed on the driver and society is also higher. And for years, we've been trying many solutions, right? Like there are toll systems, auto or even license plate based, traffic control systems, and many other systems. The problem is these are all inefficient and most importantly unpopular, and that's where technology like AI comes in. Right now AI has a very important role to play when it comes to integrated mobility, right? Like in present day, we can use so how can we use AI to optimize mobility? And this includes smart traffic control to services that that can not only indicate which are the congested routes, but they can also take you to the in a way that the overall road network is balanced, right? So and with the advancement of technologies like reinforcement learning, computer vision, agent-based simulation, deep neural networks, right? We have this what we call intelligent transportation system, right, or ITS, which is becoming a very critical part of urban mobility. And thanks to the technologies like data infrastructure and especially IoT, right? IoT, which Internet of Things, which have now allow this embedded sensor-based communication happening between vehicle and road infrastructure, leading to what we perceive as a connected vehicles or autonomous vehicle to an extent. So I want to go a little bit deeper into this intelligent transportation system, because I feel that's one of the key component of AI's role in integrated mobility. So ITS, we can be defined as as to develop correct, safe, scalable, and ubiquitous control systems, and it can be considered one way for monitoring and managing infrastructure, which includes roads, traffic signals, and etc. And another will be to manage the demand, right? Like that includes connected vehicles and autonomous vehicle and things like that. Now, traffic control alone can't solve many of the challenges, as we have learned from time and time again, right? It's there is this law called Parkinson's law that time expands, work expands at the time you allocate to them. And there's a similar trend we see when it comes to traffic. The more roads we build, the more the traffic will expand. So what we have right with this ITS integrated intelligent transportation system is you have two core components. One is ATMS, which is the Advanced Travel Management System, which looks after infrastructure and efficiency of this infrastructure. Then you have the Advanced Traveler Information System, which looks at the use of transportation systems. What is the demand and things. And I think Professor Astrid will be more expert to speak about multi-agent based simulations and other things. So I think that's another key tool we are using these days, right? I think these kind of tools can give models which can model a driver's driving style and decision making patterns to very narrow it down to how a driver will make decision, and many of them. So these are some of the ways in which AI is playing a critical role in integrated management in road systems and traffic. But I don't want to get into the fancy part where the countries like Dubai, cities like Dubai comes up with very wild, crazy ideas. So I think maybe Dr. Asar, you can speak about what kind of role this multi-agent based systems plays in smart grids and other things as well.
Definitely. So I actually took the note that this is one of the points where actually our areas touch very closely. So agent-based simulation and agent-based control, that's a differentiation that's very important to me. And one of the first things I teach the students in my courses when we talk about application of agent-based systems in energy systems. Because on the one hand, we need agent-based modeling and agent-based simulation, as you do. You do this for traffic control because you want to see how different triggers might change the behavior of the drivers actually. So that is a very important point here. And in our systems, agent-based simulation is always needed because we, like you do in mobility, we can go to the field very late actually. And to see the large-scale effects, we always have to go for agent-based modeling and simulation. But on the other hand, we have this shift then. So the agents that we develop to, for example, control energy resources, small energy resources, like, for example, photovoltaics or wind energy converters, of course, we want to take them to the field. So we have to run them on microcontrollers and to get them into a secure state, secure communication state, actually, to have them out there. So that's an interesting aspect, actually. In the agent-based control, we are working very much with, on the one hand, distributed heuristics. So on the algorithm side, it's distributed algorithms that we are working with. Some of them nature-inspired, like ant colony algorithms and stuff like that. That's fancy and it's quite interesting for the students we recognize. So nature-inspired algorithms on the one hand. But on the other hand, we have more and more aspects where the agents have to include learning models. So when you go to agent theory, on the one hand, you have agents that are quite stupid. They are more or less only reflecting what comes in, so they have simple rule-based sets. And on the other hand, we see that agents have to do planning, they have to decide, be proactive, communicate with other agents, and have a longer look on the history of events that occur to them. So that is learning agents. And one question I would have to you actually, Jibo, is this notion of multi-agent systems as on the one hand being planning systems, but being learning systems as well. What would be your rating? So I always talk about distributed artificial intelligence when I talk about learning agents, but what do you think? Is this correct, or would you say no, distributed AI is something else like learning multi-agent systems? What do you think?
So I think the biggest strength of distributed AI is it is good at solving problems that cannot be had a centralized approach, right? And which consists of a lot of components and a lot of agents as well, right? So I think distributed AI approach is very key in integrated mobility. At the same time, I think a reinforcement learning based simulations, right? That's another thing that can have this that the predictive modeling, right? Oh, that's another area I'm excited about, right? You can have this predicting modeling. I mean, predictive models might be, I mean, more efficient. It's more efficient way of managing, energy supply and smart grids and all those things. But when it comes to road, I think this kind of distributed AI and predictive models, the role will be mostly on preventive side of road accidents and other things, right? For example, in India, we lose around 150,000 lives every year due to road accidents, right? And every year we are having 500,000 road accidents, which are reported. Now the question is, how do we? I think the whole approach of India towards AI is kind of how do we use this, let's call it magical technology, to solve these problems that has been bugging us for many years, right? And when it comes to infrastructure also, our infrastructure is quite different, right? We don't have the same kind of infrastructure as, say, some country like in Germany has, but it takes time for that infrastructure development. But at the same time, can you use AI to solve these critical challenges, right? So I think even the Prime Minister himself has pointed it out, right? Like I think the integration of human and technology is needed to solve the key societal problems, right? So that's one thing. And I want to bring your attention to one interesting initiative also that's being happening right now in India. It's called iRaste. So IRASTE. It's a short form for Intelligent Solution for Road Safety through Technology and Engineering. Now, this is a predictive model to prevent road accidents, essentially. And I think it's being now run. There are pilot program being implemented in the city called Nagpur, which is in Maharashtra. And in the municipal corporation, now the vehicles will be installed with this collision avoidance technology to reduce accidents and near misses. Right now, according to the data, I think this have reduced these collisions by 60%, which is very interesting. And this is a sensor-based, IoT-based system that will identify, the dynamic risk of the road network, and help these, municipal agencies to prevent and and also identify these accident-prone zones, right, or what we call the black spots. Now, similarly, other systems are also now. I think we were looking at how intelligent traffic management systems happening in India the other day with India AI, right? So similarly, many governments, state level governments, are using AI-based, 3D radar-based systems on traffic violation and few other things. But I think the predictive models will have a long-term impact, right, when it comes to traffic modeling and accident avoidance and things like that, right? I think we want to create a smart mobility system, which I think the advantage of AI to see into future, right? If you the predictive, I think we are using these systems in manufacturing more for predictive maintenance and other things, but this kind of technology is easily translatable to road infrastructure and other things as well, right? I think one area that they can have a critical impact is in smart grids also, right? I mean, I've been looking at your works, and you have written a lot about smart grids and the role of AI as well. So can you say how that can provide more energy efficiency by using AI, how smart grids work?
Definitely. Can I shortly ask the question before?
Yeah.
Because you mentioned these fantastic numbers of reducing road accidents, actually. So I understand that this yields from predictive models, but how exactly do they yield the results? Do they change behavior of people, or of the involved cars, or of traffic light systems? So what exactly are the actors in this system?
I think it's more to do with the external infrastructure, the traffic lights, the behavior. I mean, you use these systems to kind of control the behavior of drivers, right? I mean, and I don't know how often you've been to India. It's very difficult to.
I've never been to India till now.
So there is a saying that I think the last it's a quite challenge to have a self-driving model in India, and not many have developed that. So you will face with a lot of things in the road, not just automobile. There will be street vendors and everything. So what I think this model has done is lot of the work has to do with the local government, right? The municipal body, and they identifying some of these zones. There are these black spots where more accidents happen. So that's what their primary thing is, right? And of course they have a anti-collision mechanism installed in some of these vehicles, so you get a warning, right? Like that's one thing. And one more challenge I think is a similar project that's been developed by one of these academic institute. It's called IIT Ropa. They have a project which is also now in a early stage, which detects if the driver is intoxicated. It can dictate how intoxicated he is or if he's going to fall asleep. So it can, it tracks his eye. It's pretty much, I think, it's not a complicated system. It's an eye tracking software that, look at that. So that's how these things are solved, right? But yeah, I mean, that's an interesting part, right? We all get excited about language models, but these kind of impacts AI makes goes under the radar completely.
Yeah, okay, great, thanks. You asked for examples on AI methods within smart grids. So first of all, I prefer, meanwhile, the term of cyber-physical energy systems, because smart grids is typically restricted to electric power only, and we see connected systems, so multimodal or whatever you might call them. So we have these close interconnections between heat and electricity and so on, and mobility, of course. So I really like the term cyber-physical CPES, cyber-physical energy systems, because additionally, it gives us all the methods that we see from cyber-physical systems. So that's a vast body of research and methods to especially guarantee behavior of individual systems within a large complex systems of systems. So that's very nice. So just to give you one example, I could choose from different. One project that we actually finished a few weeks ago was on the detection of adversarial attacks that might come from artificial AI systems included into energy systems. So our general idea was we see a lot of in Europe, we see a lot of developments into the direction of energy markets for system stability. So ancillary services, for example, for frequency or voltage, or if we have congestions. So these are new markets that already come into place. And we thought what might happen if we now have artificial intelligence systems that would be able to be an actor in these new markets. So what would happen? So, and one very simple example we had already many years ago in a student's work was, well, if we make our actors learn that there are problems in the system and that they might get revenues from that, they might be interested in definitely, well, working towards problems into the system. So you get money for solving a problem, so you will be somehow motivated to do all you can to put a problem into the system. So, and if you see that from a learning perspective, that's a classical reinforcement learning setting. So we tried to set up software agents that would be able to learn within these new markets. So very simple example. And what we actually saw is that our agents, without any knowledge before, started to develop a behavior where they go into the direction of inducing problems into the system. So voltage problems, for example, because they get revenue from that. So we saw that behavior. The second question now would be, okay, if AI is involved, is this really a learning process? So did the agents definitely learn? Would they apply this to new systems? And we have strong indication that this is the case, although, as you might know, really proving if this is a learning process is not that easy. But we definitely saw that this hypothesis that agents on new markets, so agents based on AI training and models, might be able to find problems in new energy markets. And that is a direction where we say AI will give a benefit because it will allow us to, well, get a system that is more stable towards attacks that we cannot think about before. That is one example. Should I get a second example, Jibo? What do you mean?
Yes, please go on.
So a more traditional example is that on virtual power plants. Did you ever hear about virtual power? Yes, I
It's
thought
like digital twin of a power plant. You're talking about digital twin technology?
In parts, it might be understood as a digital twin. The main idea is to aggregate a vast amount of small components in energy systems and to control them as a whole. So that's why they're called virtual power plants, because they are very tiny components, for example, like photovoltaics, but they are aggregated. And then they can be controlled as a whole, and the virtual power plant operation system has to decide what to do within this virtual power plant. So And you can see very different research directions here, but a lot of these virtual power plants are already out in the field. So they are working and you have them contribute to energy markets. So that definitely works, and it's a good idea to introduce renewables into energy markets. But now we see that this concept is quite monolithic, and it's quite static, and it does not yield the full flexibility potential that we see in renewables and that we see in flexible loads as well. So again, here we added to the concept of virtual power plants an agent-based concept where we allow the agents to communicate with each other and to find out what is the flexibility potential that they might deliver to the aggregation. And we included into these systems storage, for example, that is included into load stations for electromobility. And we saw quite good results for that, even for time-critical aspects. So that's quite a nice approach that, of course, has interesting technological challenges that we are happy to work on with our industry partners. Just as a second example on learning agents.
Thank you very much for that, Astrid. I think we have a comment. I think one of the viewers, one of the attendees, Logesh Mandan, has actually sent the link of iRaste, the project I was mentioning. So yeah, I think thank you for that link. I think that explains a lot. And if you have any questions or comments, please feel to drop in the chat. Now, Astrid, we were talking about a lot of the technological, highly technical side of AI in the systems. But now I have a question that's more general nature. So we are seeing a tendency of using AI for anything and everything, right? If it's required or not required, there's a tendency to say, come across and say, especially in a private sector, from a startup standpoint of view, that we use AI for this, and that gives more funding and all. My question is, what is your thought on how can we ensure now that we have this ChatGPT language models going on? Many people are kind of disturbed with this progress. That thought of AI systems being better than them, right? I mean, we speak about AI, predictive modeling, and all of the things. So these were kept in labs and in let's say universities, right? Now you have these models that writes better than you, right? I can write and behave, do cognitive work in a higher quality, and people have started to worry about it. So my question is, Dr. Astrid, is how can we ensure we build this trust? How can we ensure that people have this trust in the systems, whether we use it in mobility or energy management or language models? This problem, how we will address this problem?
Well, that's a very tough question, actually, Jibo, that you raise. Of course, the first thing here is that people only need a limited understanding of the systems that are running. So my metaphor for that is always that people, including myself, do not fully understand their cars, right? So, but we are using them nevertheless. And it does not need any detailed knowledge on the processes within the car to drive it, actually. So these are two different things, and that definitely should be something that we think about when communicating about AI. What exactly do the people need to understand? Because one of the things I feel is that people do not know how much do they have to learn about that to use it in a way that is appropriate. So that's one thing, and I can't answer you. Maybe this is, and this brings me to the second point, something that is definitely application specific. So what do we use AI for? So if we have a recommended system, for example, which public mobility system to take. So that's a recommendation. It does not lead to direct control in a critical application. So that's something different. So we do not need a system that is ensured too much, because damage is somewhat restricted that might happen. So for some applications, and we have other applications where damage might be huge, definitely, and it might even touch safety issues. So danger to life, actually, and state of health. So that is definitely a different application. And at the moment, I have the feeling that we need definitions of where to set boundaries to direct control. That is taken from AI-based systems. So where do we allow direct control and where do we allow only recommendation or direct control within boundaries? That is something that I cannot answer in general, and I think it's the same for mobility, but it's application specific. So we need experts on that, but we do not need everyone to be able to define these boundaries. I think that is definitely something where we need the experts within the application domain. That would be my view on that. I do not know. What do you think?
I think it's a question, like you pointed out, it's not an easy question and there is no one answer, right? Like building trust, and I think it's based on case by case. I think I will like to point out some things from the EU's AI policy, right, where you have a risk-based approach. Some AI tools are low risk, maybe like recommended models. This can be low risk models. At the same time, if you're using it in healthcare systems, right, like you are using it for diagnostics and maybe surveillance models. These are high risk models. So we have to have this distinction, right? Not all AI models can be treated equally, right? You have to have this distinction and have an approach on how you will. Of course, you need frameworks for sort of regulation, or how do you control the harmful effects that that these models can bring as well, right? So I think that's one way of approaching it, right, based on risk. Or I think US Bill of Rights have a different way of looking at it. So that's one. I think that's one suggestion, one point of building trust that I mostly find relatable with. But again, like you pointed out, it's not an easy question. There is no single answer for that. So I think if the audience, any of you have any questions, please share. I think Dr. Astrid and myself will be very happy to answer. So one final question, Dr. Astrid. We spoke a lot about the energy systems, distribution, smart distribution grids, and many of those things. How do you think these technologies will make a change in the next 5 to 10 years? What do you see will be the major breakthrough in your field?
Well, in my field, actually, I see a lot of, so the major breakthrough will actually be to find ways to ensure safety and security based on AI systems. So there is still some work to do to raise the confidence that these systems are applicable within safety critical systems. So that is, I think that will be the changing point once we are really able to handle this. And there are a lot of methods that already come out of research, but not enough that are now already out in the field. So that's a very important point.
I think we have a question. I think this is a question for you, Dr. Astrid. I will read the question. It's from Hannes Hobie. Hope I'm saying it correct. Pardon if I'm misspelling your name. So looking on energy systems from an economic perspective, traditionally markets have coordinating function, finding efficient equilibria between suppliers and demanders of a specific goods or good electricity or service. Example, ancillary services. Does AI will overtake this task of markets? Okay, that's a very complicated question from my point of view, but maybe Dr. Astrid can help me with that.
I think I understand Hannes' idea, and maybe I phrase it in my own words for everyone. So I think Hannes' question is, if AI is able to find an overall optimized system state, so even from economic perspective, do we will have markets in the end? So Hannes, I hope this question was the same as
Thank you for that. Thank you for defining it. Yeah.
Nice.
Yep,
okay.
please.
Correct phrasing as well. So my understanding is that we will still have markets, but we will not avoid, and we should not avoid, to have AI-based actors on these markets. So we have to be prepared for introducing regulatory aspects that we already have in markets. So markets are highly regulated. That's the core idea behind that. And we have to find out how to integrate AI-based systems into these regulated markets. So where are the boundaries again? That's definitely the same point here. Where these markets will still function and show the behavior from this economic perspective. So we are going into the direction of economic efficiency here. That's what we want to yield with the markets. And we will have to understand that already now we do have AI. So algorithmic trading, for example, there are AI-based methods already out there. And so the markets will be sooner or later dominated by AI-based systems. And it's not easy to set up regulatory systems that will be able to bring together these two worlds.
Well, I think that's a very good answer. I mean, I am able to understand as well. I think our audience was also able to understand, and I hope we have answered your question, Anas. So if you, I think we are out of our time.
Chibu, if I just would like to interfere, so if the attendees have questions, they just can raise their hands and we can give the mic rights because we have a smaller group of people here and then the questions might also flow. So if there are more questions, please raise your hand and we can give the people for more interactive sessions the rights to the mic.
That'll be wonderful. That'll be wonderful. Yeah. So yeah, any more questions? Please feel free to raise your hands. Or anyone, if you want to add a comment also, we can do that. Yeah, I think we have questions. Jonas Roof, should we give him, I think we can give him the rights to
We
ask
can give him the rights, Tanya, to maybe ask the question directly.
Jonas?
Hi, can you hear me?
Yes.
I had a bit of problems with my microphone. Like you can read my question. I wanted to know from you, what do you think is the biggest thing AI can do for us to make big steps towards more sustainable mobility?
So I think I will share my thoughts first, then we can go to Dr. Asad. So Jonas, I think we spoke about intelligent mobility systems, right? I think what will be these things will become a critical component of our urban mobility going forward, right? When we look into this kind of creating smart cities and other big, how do I say, connected cities and connected environments, right? I think that will be the next biggest thing that will be the next big step going forward. And with this kind of technology, this kind of AI technologies, we will be getting this optimized way of moving. Like whole thing is about moving from A to B. So we will have optimized traffic management. I mean, we right now, let's say something similar as traffic lights. It's based on a pre-programmed behavior. Now imagine we have traffic signals and similar infrastructure which acts based on the behavior of the people or the drivers around it. Right now you have connected cars and these modeling systems that will be able to predict which is the peak time, which is the time when something significant happen, or let's say there's a football game happening, the traffic towards the stadium will be more. So these kinds of things will be able to be predicted in advance, and then you can have this kind of infrastructure that will help route traffic, avoid road congestion and things like that. So that's one big thing I'm seeing in the near future happen. And I think to get started on something like that, I mean, we don't need that kind of advanced technology or infrastructure or anything like that. Dr. Astor, if you want to add anything to that.
Well, you're the mobility expert, Jibu. But maybe one addition only. So sustainable mobility, of course, brings us quite directly into the area of climate neutrality and so on. So efficiency from that perspective, but it's not all. So as you said, Jibu, it's on, for example, spending less lifetime in traffic jams. So that's definitely part of the sustainability discussion. So make better use of your lifetime and feel better. And of course, this has to do with health in the end. That's part of mobility as well. So I think there are many tiny aspects that can be changed, and it's more a continuous process of optimizing an overall system than one big thing that will change.
Yep. So I think I think Astrid mentioned that big point. It's not just about one big thing, rather than many things being optimized or being made efficient in multiple points of view. I think when you speak about AI and mobility, people generally jump into autonomous vehicle and self-driving cars, and we think it can solve the problem. I think we have another question from Rajesh Banwal. Can we give him the audio rights, Tanya, if you can? Rajesh? Okay, I think I will read out the question here. This is an interesting question. Do you think that in near future, the AI can manage congestions in extreme traffic conditions, like in India with constrained resource conditions? Very good question, right? Like I think we have a very different way of driving in India, right? So I think few things, Rajesh, is that I mentioned iRaste, which is an accident prevention system, but there are few other systems. That are now being implemented, right? I think many of the state governments are also have these initiatives that looks into addressing these things. For example, one of the thing is this my home state, the state of Kerala, has this AI camera surveillance system, which is about to be implemented in the coming year. So that will kind of reduce road accidents. So they're planning to implement use this AI based cameras to reduce road accidents by half by 2024. So that's one thing. Similarly, Bangalore traffic police recently introduced an AI enabled traffic management system. Now what these tools looks at is traffic violation. And for your information, Dr. Astrid, traffic violation is very common in India, and it's even wearing helmets or something very basic as wearing helmets, seat belts are kind of rare in some parts of the country. So, and we don't have the enough resource to enforce many of these laws. So that's why we have AI tools now, camera systems that will capture the violation and capture the number plates, and it goes beyond just traffic signals, but to other traffic violations as well. Similarly, like I mentioned, the Delhi police one, and another one is Karnataka's Road Transport Corporation has AI based technology to limit road accidents. Like these are the bus station. This is bus corporation. They have many buses by the government, so they have this collision warning system, driver drowsiness system, which is an eye tracking system, and they have been fixing that for over 1,000 buses. And these will avoid, give you a warning, right? At least, like they say, if you can give a collision warning at least 2 seconds before, you can like prevent an accident. So these are the kind of things which is being implemented right now in India. And I think going forward, as we have more 5G rollout and the development of IoT, we can build more systems in India as well. We have one more question. Anup Kumar Das.
Jibu, I'd like to comment on
Yes.
Lukesh said he believe or she, sorry,
AI 5G, yeah.
AI, 5G and IoT, and I'd like to add something. So I fully agree, but I'd like to add data management, data quality management, actually, because we are talking so much about all these learning systems, but we're not talking enough about how data quality and privacy, where needed, is actually taken into account here. So that needs processes as well. So an important thing in energies, of course, as well. We're talking about that.
Yep. And another question is from Anup Kumar Das. I think Anup Kumar, you are asking about, yes, if you can ask the question.
Yeah, this is the question. If you hear me,
Yes.
how is AI improving the mobility in the matured markets? Because most of the developed countries, they are utilizing AI-based systems, and also we have many inland waterways across the country, like in river waterways. So, is there any system having AI-enabled system or any kind of activities? Thank you.
So, Dr. Astrid, do you have anything to add? Because I am not a part of matured markets, so.
For the e-mobility markets, no, actually, I hope that you were the expert as well.
So yeah, so I think Anu Kumar, I think I don't have heard much about inland waterways engaging AI-enabled system. I think even in matured countries or markets or even India, I think waterways are very underutilized. But at the same time, there's also the problem of water, sustainability also there. Like how do you utilize the waterways, right? Like these waterways can be also source of water for drinking water from numerous things for a city as well. So I think I'm not very much aware about inland waterways in this particular space. But I think many of these points I mentioned, this monitoring systems, integrated transport management, traffic management systems are being implemented in various cities across the world. Maybe especially with this many smart city projects, I think especially even in not just the West, but in countries like Japan and South Korea also, you can see many of these projects incorporated very much. I mean, I think one similar, very simple example I noticed. It's not about road management, but it's mostly about pedestrian management. If you go to Korea, you have these traffic signals which are kept on the floor, which works based on a person coming there, right? Like, so this is a realization that people are looking mostly at their phone. So these traffic signals work, and if you're crossing it, it will make a noise, right? It's like you don't have a traffic light in front of you, it's on the floor, and so that you can browse on your phone and see the light. But again, if you are crossing, it will make noise, so and it will automatically connect with other signals, enabling the other rights to become red. So these kind of systems are implemented, which are some of the interesting case studies. And I think before we wind up, I want to make a comment. I think Abhishek Anand has sent a message saying about EV and do India have dry cycle data, battery charge, discharge data for research purpose? We don't have that, but we will certainly look into that. So I will hand over to Astrid for the closing comments. Over to you, Astrid.
Sorry, I didn't get that.
So I was saying, I think it's time we can wind up, and I was inviting you for your closing comments.
Okay, thanks a lot, Jibo. Yes, a very interesting exchange. Definitely, Jibo, I would like to invite you to Oldenburg. So if you want to join, or some of the colleagues that work in that area, we have a research center here that's working on systems engineering in the mobility domain. So it's one of the DLR institutes. So that might be very interesting for you. So we would be happy to welcome you. So feel free to contact me. And well, despite that, I think there are several interesting interaction points within the technology sectors of energy systems and mobility. And I'm very happy to go into that discussion. Would be happy to go on with that.
Okay, thank you very much, Dr. Astrid. It's a very great privilege for me to part of this conversation, and thank you everyone who has joined as well. So those who want to know about AI in India, you can go and visit India AI, which is a national AI initiative, indiaai.gov.org. And like I said, if you want to carry on some of the topics we discussed, or some other AI related conversation, you can look me up in, we can look both of us in LinkedIn or wherever you can find us, and drop a line regarding that. So thank you very much for joining. I think over to you, Katya. Thank you very much.
Yeah, thanks so much for the really engaging discussion. It was lovely to see how you interacted and how we combined energy and mobility, no? And also thanks to the audience for the engaging discussions. We will look into the topic further with small interventions here and there. Thanks so much, Professor Niese, for connecting to us from Oldenburg, and for taking the challenge to look a bit into India. Thanks, Jibo, as always, for the good moderation and the good inputs. We have a long-standing cooperation with AI Portal India. I really can recommend the portal. There's a lot of offer also on international perspectives, I have to say, not just looking into India. Jibo just was in Germany connecting with AIs to connect it. So lovely to see. That brings me to an end for this year's forum on sustainable urban mobility. I think we looked up in a lot of different aspects in these 2 days, going from the broad aspects of energy transition. There's the other panel just closing at the moment on adaptation and technology diffusion, but also talking about modeling and so on. So as I mentioned, the platform will be online for the next month. So if you would like to reach out amongst each others to the people, log into Converve. You can run through the profiles, and you can still have chats with the people on the platform. We will take the topic forward, so stay updated what the German Center for Research and Innovation is up to. As always, we connect the Indian and German research landscape further. So thanks a lot for the wonderful panel.